Hello friends, chapter number 13 and topic number 8, that is Fleming's rules. We have already studied about the magnetic field due to current carrying conductor. If it is a straight or a band, it was very clear that the direction of current, if it is something like this, then the circling finger of the right hand used to give the direction of the magnetic field, right? We have already studied about this. If this is the direction of current in a conductor, then these circling fingers of right hand will provide the direction of the magnetism which will be induced around the conductor, right? This was our study number 1 in previous videos, and it was known as right hand thumb rule. That thumb represents the direction of current, then these circling fingers will represent the direction of the magnetic field which will be induced in a circular way around that conductor. Now, when we are talking about the magnetic field which is produced by a current carrying circular coil, then also it was very clear that if this long straight conductor is bent like this, then in the same way, according to right hand thumb rule, direction of generation of electricity will be given by this right hand thumb rule, and hence the direction of current, if it is like this and it is circular in shape like this, then the direction of current will be like this, right? You will have to visualize this situation in your mind. Now let us talk about the solenoid. What is solenoid? Solenoid is nothing but a soft core material on which we have wrapped a copper coil around it. Now when we are passing the current in those conductors, means we have applied the current, we have now given the supply of a current, then the direction of currents may be given by these fingers. Then the direction of the magnetism which will be induced due to this current will be given by the right hand thumb, right? So this will represent the N, that is the direction of the magnetic field which will be emerged from this solenoid. So here also you will have to use right hand. Now let us talk about the Fleming's left hand rule. Fleming's left hand rule is utilized for finding out the direction of the motion of a conductor when we are giving supply to the motor. So Fleming's left hand rule is utilized for finding out the direction in case of the motors of the conductor. For example, forefinger, that is F. Forefinger represents magnetic field, that is F. Then central finger I, central finger, that is current, central C, current. Central finger represents current, and thumb M represents the motion of the conductor. So in case of motor, if the direction of field is represented like this, field, central finger represents the supply current, then the direction of the movement of that conductor will be given by the Fleming's left hand rule, that is thumb M. Next, in case of schematic diagram, it is very clear that the S pole, south pole, the conductor near the south pole is having the direction of current like this. So central finger direction like this, field is like this, then that conductor will experience the force in the upward direction. Now let us talk about the conductor which has been placed near the north pole. So it is very clear that the direction of magnetism is something like this, that is north to south. Now the direction of current is like this. So movement of the conductor will be downward direction. So near south pole it will be in upward direction, near north it will be in downward direction. So the motor, the armature will start rotating. It will rotate like this, right? So this direction, the movement of the armature, the movement of the movement of the armature can be found out with the help of the Fleming's left hand rule. Now this is the animation which represents the situation which we have already talked about. This represents the movement of the motor. Now, electromagnetic induction. In case of the electromagnetic induction, it was very clear that the direction of the induced current or induced EMF, EMF means electromotive force, the direction of the current which induces due to changing magnetism, changes whenever there is a change in the direction of the magnet, right? And in case of the electromagnetic induction, it was very clearly understood that the direction of current which induces in the coil number 2 is dependent on the direction of the magnetism which induces in the coil number 1. In short, whenever there is a linkage of electricity and these linkages produces the magnetism in coil 1, this magnetism linkages or associates with the coil number 2, and this association of the magnetism of coil number 1 towards the coil number 2 induces electricity in coil number 2. Now, the Fleming's right-hand rule. Fleming's right-hand rule is utilized for finding out the direction of the generated electricity, generated current, right? As we have already talked about that the forefinger or first finger represents field, thumb represents M, that is motion, and central finger represents current, and all of these three fingers are placed perpendicular to each other. Then central finger will give us the direction of the induced current. So in case of electrical generator, for example, if this is the direction of field, that is north to south, right? So north to south, this is the direction of the field. Now if the direction of movement is like this, then the direction of the generated current will be like this. So you will have to visualize this in your own mind. You will have to apply the Fleming's left and right hand rule in your mind to find out the direction of induced current in case of the generator and the direction of the movement of armature in case of electrical motor. But now the main thing that comes in our mind that भैया हम तो इसमें बहुत कंफ्यूज या जाते हैं, कंफ्यूजन हो जाता है कि कहाँ ससुरा ये लेफ्ट हैंड अप्लाई करना है और कहाँ ससुरा ये राइट हैंड अप्लाई करना है. बड़ा ही दिमाग मतलब कि घूम जाता है कि कहाँ लेफ्ट कहाँ राइट कहाँ लेफ्ट. तो इसके लिए एक हमारे पास सॉल्यूशन बा है, और वो सॉल्यूशन बा क्या है? ग्रेहम बेल. नाउ हु इज द ग्रेहम बेल? ग्रेहम बेल इज द इन्वेंटर हु इन्वेंटेड टेलीफोन, राइट? Graham Bell was the inventor who invented telephone, right? Now the word, the alphabets in his name may give us clue, an easy clue to remember where to apply left hand rule and where to apply right hand rule. See, this technique I have devised. You may devise your own technique. Now the alphabets: Graham Bell, GR, generator right, GR, generator right, means you will have to apply the Fleming's right hand rule in case of generator. Graham Bell, M, Graham motor, Bell, left. So Graham Bell, motor and left. So you will have to use left hand rule in case of motor. You will have to use left hand rule, else otherwise everywhere you will have to use your right hand rule. Okay, so Fleming's right hand rule is utilized in case of the generator, and Fleming's left hand rule can be utilized for the finding out the direction of the motion in case of motors. There are hundreds of different techniques which you may create by own. This technique I have created, you may create your own. For example, Gujarati students may remember this as, because nowadays almost everybody used to watch Tarak Mehta Ka Ulta Chashma, and Jethalal used to almost speak Gujarati everywhere. So Jethalal speaks, Mehta Sahab mera dahina haath hai, Mehta Sahab maro jamno haath છે, right? So jamno means right hand. So motor જે છે એમાં ડાબો, બાકી જનરેટરમાં જમણો, means જનરેટરમાં જમણો, મોટરમાં ડાબો. Automatically it will be like this. You may create your own method to remember all this type of terminology. I hope you would have understood and remember where to apply Fleming's left hand rule and where to apply Fleming's right hand rule. For more such videos, please keep watching Free Education by Arkasar. Thank you.